In this video, I want to share the geometry concept of area. So I'll just go through the brief conceptual overview and then some practical problem solving. So let's dive into the video. Before diving into the mathematical problem solving regarding the area in geometry, I just want to briefly give a conceptual overview of the concept of area or the geometrical area. So if I just go to Google and write what is the concept of area in geometry, so the AI overview gives is here is in geometry, area refers to the amount of two-dimensional space or shape a surface occupies. So a surface occupies two-dimensional space, so that amount refers to the area in geometry. So it's essentially the measure of how much a flat space a shape covers. Area is always expressed in square units like square meters or square feet, etc. So this is the very basic overview of the concept of area in geometry. So if I now try to solve the first problem, so the first problem states that a right angle triangle is formed by the diameters of three semicircular regions A, B and C, and this is a right triangle. So A, B and C as shown in the diagram. So you have to prove that what, or show that area of region A, this area is equal to area of region B and plus area of region C. So this is what you have to prove. So now if I use the pen tool, the problem states that is if I just draw this diagram. So this is a right triangle. Let's say this is the right triangle. This is a semicircle here. There is a semicircle here, and there is a semicircle here. So the area of this region is A. The area of this region is B, and the area of this region is C. So you have to prove that the area A equals B, the area of or the region of B plus the region of C. Now what we can do here is, we know that this is a right triangle. So if this edge, not the region but this edge is A, and let's assume this edge is B and this edge is C. So according to the formula of Pythagoras, we can write what? A square equals B square plus C square. Now I can of course write A square equals B square plus C square. Now what is this A? This is a semicircle, so this is the diameter. This is the diameter. If this is the whole circle, this is the diameter. So what we can do here is, if I divide the both sides with 4, I get what? A square by 4 equals what? Square by 4 plus C square by 4. B square plus C square by 4 can be written as B square by 4 plus C square by 4. Now this can be written as what? A by 2 whole square, right? A by 2 whole square equals B by 2 whole square plus C by 2 whole square, right? So A by 2 whole square, okay. So now A by 2 refers to as the radius, like this part. A by 2, B by 2 similarly is this part, and C by 2 is this part. So now what we can do here is we can multiply both sides with pi. So if I multiply both sides with pi, I get what? Pi into A by 2 whole square equals pi into B by 2 whole square plus pi into C by 2 whole square. Now this is a formula of what? Circle, the area of the circle. So, or pi r square. So pi into this radius square is what? Area of A equals pi into B by 2 whole square is what? The area of B plus pi into C by 2 whole square is the area of C. So we can prove that the area of region A, or the region A, equals the region B plus the region C. This is how you can solve this problem using the Pythagoras formula and the formula of circle. Because these are semicircles, we can use the formula of circles. I now want to focus on the second problem. So let's read the problem. It states that there is a diagram here that shows the plan of Jason's garden. So ABCO and DEF are rectangles. So this and these are rectangles. CDO is a right angle triangle. CDO is what? Right angle triangle. And AFO is the sector of a circle. This AFO is the sector of a circle, and this angle is 90 degree, AOF. Okay, AOF is 90 degree given. So Jason is going to cover, he's going to cover the entire garden with grass seed. So each bag of grass seed cover 14 meter squares of garden. So each bag covers 14 meter square. This is the 14 meter square, is the area that each bag of grass uh, covers, and each bag costs what? Each bag of grass costs 10.95 pounds. So work out how much will it cost Jason to buy all the bags of grass and seeds he needs. So if he has to cover all the area, how much cost will it take? So if I use my pen tool, we have to find out individually the area of all these four parts. So we can easily find out all of the area of all of these four parts. So let's start with the two rectangles. So what is the area of ABCO? We have the length and we have the width, so we can find the area. So what is the area? Let's say the area of what? ABCO. The area is what? Length multiplied by width. Okay, length given, width given. So the area is what? Length multiplied by width, which is what? 77 meter square, because they are meters, right? And what is the area of DEFO? The length given, the width given. So the area of, let's say the area of DEFO is what? Length given here is a 9 meter and width is what? 9 meter and width is 7, so it is 63 meter square. So if I figure out the area of the two rectangles. Now let's focus on the area of the triangle. So the base here is what? 11 meters, because this is 11, so this should also be 11. And the height here is what? 9. So 11 and 9. So what is the area of the triangle? The area of the triangle CDO DO is what? Is half into 11 into the height is 9. The height is 9. So we can write what? This is 99 by 2 meter square, which is roughly, which is 43, not 43 but 44.5. Can also be written as what? 44.5 meter square. This is 44.5 meter square, half into 11 into 9. Okay, now we have to figure out the area of AFO. So this is a part of a circle, and as you can see, this is the right angle 90 degrees, and these are what? These are what? Radiuses of that, of this arc of the circle. So if these are radiuses, so what can we do? If these are radiuses, and this value is what? 7. This value is also 7. So these are radiuses, and this is the arc, one arc of the circle. Okay, one arc of the circle. So we can figure out the area. We can figure out the area of AFO as what? This is 90 degree. We know the circle has what? A total of 360 degree in the center. So 90 degree basically is what? 1/4. 1/4 of what? The area of the entire circle. So the area of the entire circle is what? Pi into what? Into this is deemed as radius. So the radius here is 7. So it's pi into 7 square. So this can also be 1/4 multiplied by pi multiplied by 49. So this is what? 49 by 4 into pi, so which is approximately what? If I use the calculator, let's just use the calculator to give an approximation. So 49 divided by 4 is 12.25 into 3.14. What do I get? 38.46. So this is approximately, let's just use this sign, 38.46. So we have figured out all the individual areas. So what is the total? Let's say total is t. The total should be what? The addition of all this. This is also meter square. So if we add all of them, let's say 77 plus 63, 77 plus 63 plus 44.5 plus, let's say this is approximately 38.5. So this whole can be referred to as meter square. So if I just add all of it, this would be an approximation. So if I just use the calculator and add, if I just remove this, 77 plus 63 plus 44.5 plus 38.5, this is roughly 223. So this is roughly 223 meter square. So this is the total area. So if 14 meter squares of garden, each bag covers 14 meter square. So 14 meter square covers what? One bag, or one bag covers 14 meter square. So 14 meter square requires one bag. So 1 meter square requires, if I use the unitary method, 1 meter square covers 1 by 14, and 223 meter square covers what? 223 divided by 14. If I just use the calculator again and I divide the 223 by 14, I get what? 15.92. So it's roughly 16 bags. 16 bags. Let's say this is 16 bags. So one bag costs what? One bag costs 10.95 pounds. So if one bag costs 10.95 pounds, so how much would 16 bags cost? 10.95 multiplied by 16. Let's say this is multiplication 16. So if I calculate, use the calculator, let's say this multiplied by 10.95, I get what? 174.41. So it's approximately 174 pounds. So this is the total cost that Jason would incur if he wants to cover all the entire area with grass seed. I hope by now you have a good understanding of how you can solve the problems regarding geometric area. So in the next video I'll focus on some more problems regarding this concept. So stay tuned for that.